Hello everyone, welcome back to my channel again. Today we are going to do some tests about the two transformer structure models. One is called BERT, the other is GPT-2. On my right hand side, now I'm going to run the code and prepare the interface, so later we are going to try it out. I'm going to run now. On the left hand side, we can quickly browse the model information. In Wikipedia, like GPT-2, you can see that it is developed by OpenAI, and it is second in the foundational series of GPT models. The later ones are GPT-3 and GPT-4, now GPT-4o and GPT-4o1. Okay, we're going to test the GPT-4o1 in the later series. Okay, so in this model, if we really want to dig up and discuss all the details, there are a lot of things. Okay, it actually involves a lot of design of the model and how it is trained and so on. Okay, then there is another model called BERT. BERT model is developed by Google in 2018. It is a very famous transformer model, and for most of the courses in university, now it is a master learn topic. Okay, it is the official name is a bidirectional encoder representation from transformers. Okay, and it is trained on the mask token prediction and next sentence prediction. So basically, either BERT, GPT-2, GPT-3, in my opinion, they have a different design, or progressively they have some improvements on specific task. So whenever you approach a model, it's better that you understand what it is meant to do. Okay, so it is designed for specific task or generative generation of text, or specifically on some task. For example, now we can also see some large language model hosted in Hugging Face, and we can see actually there are some models you see specific on the coding task, fine-tuned for different purpose and so on. So whatever model that is, we need to understand what it's designed for and the basic structure. Okay, if you want to review in detail, it takes a lot of time. But if you only want to use it, it's better to understand its purpose and its limitations and pros and cons. Okay, so before now the code has some problem, I'm going to rerun it. Before that, let's quickly take a look at the models we are going to introduce today. So basically, we have GPT-2, GPT-3, GPT-J, and BERT. Okay, I just put them all here for some comparison. Okay, the larger the model, the more the parameters you are going to see involved inside of this model. And as you can see in my tutorial today, I'm going to show you the GPT-2 and BERT. The reason is that in Collab environment, I can load these models easily. I can even interact with some user interface and to try it out. But for GPT-3, it is not, first of all, the Collab free tier does not allow to load this model. Okay, it is very big. Second of all, we do not have a direct source to get this model. But for GPT-J, I already tried, and Collab already crashed several times. But anyway, if you have a larger quota of the computation resource, you can try it. Okay, I also leave it here. So I'm going to rerun it and let's test it. So first of all, let's check the BERT question plus context simple version. So as you can see, this code is quite simple, right? We first of all import the necessary dependencies, and in Collab, I think Torch and Transformer are already installed. The reason you saw the previous error is because I did not install Gladio. Okay, Gladio is not a default package in Collab environment. Anyway, here you can see we import different packages and tools, and we specify which is the model we want to test. Okay, and also the tokenizer that we want to use. Okay, and you can see here, the reason you see the title is question plus context simple is that this model actually is suitable for the task where you specify a question and also the context. So the model will put your question into this workflow of the model, and to query is like querying the context. And the input the input to the model is actually to tokenize both the question and the context. So tokenize is to break down the sentence to word. If you consider word as a token, it is breaking the sentence to the word level. Okay, but the tokenizer may have different variations. Then perform inference is a step of asking questions. Okay, so this is a part we are going to ask the model, and this part is to use the torch function to actually extract the logics and find the answer span, and then decoding the answer with the last step. Okay, so you can always check which is the exact definition of each sentence. So I'm just going to quickly pass to the test part. So in this case, I already predefined both the question and the context. So this model will do one thing: asking this question with the context that we provided, and the model will output the answer. Okay, what is machine learning? A field of artificial intelligence. We can see here, machine learning is a field of artificial intelligence. This is quite an easy task, right? Okay, let's expand this example. Now we involve also Gladio. Okay, first of all we install the dependency, and we see, okay, this code is almost the same as the previous one. The difference is that now I involve one of the functions to script the Wikipedia website about the linear regression. I'm going to ask some questions around this topic. I'm going to see how it performed. Then the BERT question answering is similar to the previous one, and also the inference part. Okay. So now, but the inference part, you see the description is ask a question based on the context of linear regression Wikipedia article. Okay, this is just to mention how the question and the context will be linked. Then we launch the interface of Gladio. So let's try one question. What is linear regression? Okay, and we submit. It is a very beautiful AI. I really like it. And you can see also in the large language model playground and the different sources, you can see a lot of application of Gladio. Okay, so let's see how it performs. It's not very quickly. We get an error. So I think it may be influenced by the code that I run after it. So I'm going to rerun this part and launch the application once again. Okay, so I actually deleted my runtime, cleared all the information by here. Okay, disconnect and delete runtime and rerun it. Okay, so I suggest you, when you test this notebook, just make sure that you test each part individually. Okay, when you finish this part, you go to the next part, not running everything together. So as you can see, I ask a question: what is a linear regression? A statistical model which estimates the linear relationship between a scalar response and a variable and one or more explanatory variable, regressor or independent variables. Not so bad, right? So it actually query the context that I provided is in the Wikipedia webpage. As you can see, if you ask a more advanced model with the function call to get the online information, the output will be more will be more abundant. Okay, the context will be longer, especially when you adjust the temperature. I'm not adjusting anything here. Okay, I just load the model and run it in a plain vanilla way, just quickly to view the effect or how the result is going to be shown. And you can see it is like a quick query, right? Not necessarily quicker than you just search on the browser, okay? But it is doing some of the query. So let's try another question, okay? What are the metrics for evaluating linear regression? Let's see how it goes. As you can see a shadow bar to show the progress, okay? Not so bad. Mean squared error, okay, is one of the metrics to evaluate a linear regression. You can also have R square and different metrics, okay. Okay, so far so good. So very quick view of the BERT model. to query on the context. Okay, you can also try on your side. So now let's try GPT-2. Okay, in GPT-2, the basic structure is also like querying the BERT. The difference here is that I now add a widget, okay, to actually make it shown in the output window, so I can input my my query, my prompt. But as you can see, if you use the Gladio, it is more user-friendly, right? Much nicer to look at. So now here, GPT-2 is different because you do not need to give a context. Okay, so let's try here. Ask the similar question. Okay, what is linear regression? And we click get answer. And we're going to get a response. Yeah, you see, what is linear regression? The answer is that linear regression is a way to measure the relationship between a given variable and its value. It's a way to measure blah blah blah. And as you can see here, it keeps repeating itself. Okay, it is a way to measure the relationship, and it is a way to measure the relationship. It goes on and on, right? And let's try another question. What are the metrics to evaluate linear regression? Let's see how it goes. Yeah, you see, the first metric is the number of times the regression is repeated, and not what I was expecting, right? The second metric is the number of times the regression is repeated. It is like repeating a sentence and only change some words. It is quite fun to test. Okay, just to understand. Okay, GPT-2 actually it has been trained with a different data set, different structure, and how it decipher your prompt in the model and give you a response. Okay, it's quite different from the previous one. So let's try with Gladio. Okay, so basically in Gladio it will be shown better like this. Okay, at this part, let's see. We actually expand some of the parameter like temperature, maximum length, and so on. Okay, so my original hope is that we have this is like a navigation pane. Whenever you see, like in Hugging Face or in other place, you can see for each large language model, if you want to chat with them, you're going to see this parameter adjusting pane. Okay, and you can try to change different parameter. Okay, and since the code was mostly generated by GPT, the interaction with GPT and the refinement. So if you go to the GPT-2 model documentation hosting Hugging Face, you are going to see here, like the model generator, this function. Actually, you do not have so many parameters. So for GPT-2, I am not sure if all these parameters will be taken by the model. But of course, you can do different tests. You can either follow more strictly with the documentation, or you just ask GPT to generate this function. Both ways are fine, okay, to make it work. And if you want a more robust test, just try to modify this part. Okay, this is not a final and rigorous version of the output generation function. Okay, it is only for your reference. Okay, so let's see here. I do not change anything, okay? I say again, what is a linear regression? A good thing about the Gladio is that once you click enter, the model goes on to generate, okay? You go to the phase of inferencing. However, if you use a widget or something else, you need to click the button. Okay, you need to put more focus on the design of the interface. But Gladio seems much better and easy to get on. Okay, so what is linear regression? Yeah, it is more or less like before, and you see here it kind of repeats itself. So let's see, we actually shorten the response size, max length. Okay, yeah, it is much shorter, but you can see the repetition is inevitable, right? So let's try what are the metrics to evaluate linear regression. Okay, let's see how it goes. Yeah, it is like the previous one, right? Now we only change the interface for user-friendly interface so we can test. Okay, so now here we tried both the BERT and the GPT-2 model. It is quite interesting that you play with different model to understand how, for example, before GPT-4 and more advanced model, when we look at the older model, it's like that you examine the history of the large language model and you can get a better sense. So an easy way is to get the code fast and then try it by yourself, feel how it adapts to your user case. A more Another way is to take more time to read the documentation, read the published paper. It will take a lot of time. If you are not really doing research about the models and you focus on your user case, I would recommend you to test it in different sources. Okay, there are also some sources where you see the models are hosted in a website. You can try it, or you can try it here with this notebook and adjusting some of the parameter and test it out. Okay, so you need to understand what you really want and what is your use case, and if such test is useful for you. Last thing is that I'm going to show you this failed example about the other model is a GPT-J 6 billion parameter version. Okay, it exploded because the RAM. You see, the free tier Collab has 12 gigabytes of RAM available. It quickly just exploded to go over the RAM, so the loading is not successful. Okay, you can try if you have enough resources, computational resources. Now let's take a look at the note. The note is generated by GPT with referencing of the different sources. Of course, it also queried the Wikipedia and so on. So if you want to try to take a closer look at how it is designed, you can check it here. But a rule of thumb, when you see the models, if you do not care about the design, the structure, the computational, how can I say, the structure and so on, you just check the parameters. The bigger the more the parameters, the larger the model, the harder it is trained, the more computational resources you need to train, fine tune, or even doing inferencing. Okay, it's just a quick rule of thumb. And here we also have a comparison table like I introduced you in the beginning. So primary use case, let's check about GPT-2. It's about text generation, language task. Okay, how about BERT? It's extracting Q&A, understanding task. And if we are using it at home, for example, I would prefer to use the BERT model because it you can set the context, right? You know, if you want to query a knowledge, maybe Wikipedia is a quick source. If you want to like query a research paper, you can just pass the PDF and get the information and ask the model. But of course, its performance is much less ideal or less advanced than the later model like GPT-4 and so on. So we should have fun to test all the models. Wish this tutorial is useful for you. And if you have any question, feel free to ask me. If you like my video, just subscribe and see you next time. Bye bye.